Hey everyone, welcome to week 5 of R Davis. So we're going to continue talking about data manipulation and wrangling and using various functions within the tidyverse. And so this video is focused on conditional statements, which essentially are a way to run a test, and if something is true in the test, then do this. And if something is false in the test, then do that. And so it's a way that we can classify and reclassify data. And it's something that we've been exposed to already in class when we've talked about like filtering and things like that. And so this is kind of just the next level up. So for this video, we need to load up the library of tidyverse. And we also need to read in the surveys data set. Okay. And let's just see what the data frame looks like again, because it's been a little while since I looked at it. Okay, so we have a bunch of rows, we have 13 columns of data, and for this tutorial, we're going to be focused on this column of hind foot length, which we can see here is numerical. Okay, so let's actually look at the summary of hind foot length so we can get a sense of the data here. So we see the minimum value is 2, and we see the max is 70, and we also see that there are a lot of NAs. So that's good to know. So let's do a practice of doing a conditional statement, reclassifying these data variables from numeric into some sort of category. And I suggest when you're thinking about conditional statements, starting with some pseudocode, which is essentially kind of writing out your steps that you want your code to do before you actually write the code for it. So let's do an example of this. So pseudocode. So essentially, we want to do an if-else statement where we submit some sort of test or condition, and then we'll tell it what to do if the test is yes or true, and then what to do if it's false slash not true. And so first we can just look at a Boolean test to get a sense of what this looks like. So we want to look at surveys, hind foot length, and say we want to capture something about values that are less than or greater than the mean. So in this case, we know the mean is 29.29 because we ran that summary function. And so when we do this, we can see that we get a mix of true, false, and NAs. And so essentially, this is going through and saying what values are greater than 29.29, true, values that are less than, false. And so when we put this into an actual test, we can first create a new column where we'll save the results. So this is what we learned about last week's, how we can pull up the data frame and we can actually set a new column here. So I'm going to call it hindfoot categorical. And whatever test we do on the right side of this arrow is now going to be saved underneath this new variable in the data frame called hindfoot categorical. So we'll write if else surveys, oops, hindfoot length less than 29.29. If it's yes, we want it to be equal to small. If it's no, we want it to be equal to big. So we can run this and then check out the results. So hindfoot cat. Gotta spell head correctly. And so we see that the results that R spits out are big, big, and then NAs. And so just to verify that it is labeling the right category as big, we can also look at the original column. And so we see that the values were 32 and 31, and in fact, those are greater than 29. And so that's correct to put it into the big column. And so this is, one way to go about it. And one thing I want to point out is that we have in line 12, we have hard coded what the mean of this column is. But another way that we can write this that's a little more robust is taking the exact same code that we wrote. So hindfoot length, else, surveys. Instead of writing the number, we can actually just write how we calculate it. So we know that this is the mean of this category, this column. And we know that there are NAs, so we need to remove them. So we can set NA.remove equals true. And then we just copy the same exact arguments that we wrote before. And so this way of specifying the condition will, in theory, give you the exact same result. So let's look again and see if it lines up. So it does. So this is just another way to set the conditional statement. And there is a challenge in this tutorial that will ask you to look at the different quartiles. And so you can follow a similar method for calculating those and writing them into the conditional statement. So this is, a pretty good function. If else is really helpful if you have two conditions. But once you start having more than two conditions or two categories that you want to create, it gets pretty messy. And so tidyverse has a really nice function called case when that allows you to set as many arguments as you need or tests that you want to do. And so the way that this looks is essentially we set up our code like we have been with working with the tidyverse. So we can specify the data frame and then the pipe function. And then we can space down to a new line and use the function mutate to specify the new column. And so we called that new column hindfoot cat. And this is where we'll write case when instead of the if else function. And every time I specify a test in case when, I typically like to put it on its own line. And that way you can comment anything related to that test. And it's also just easier visually to see what you're doing in the code. And so our first test was basically, is hindfoot length, greater than 29.29? And if it is, let's label it big. And then if it's not, let's label it small. So you might say this is kind of weird syntax, and I agree that this is not as intuitive as the if-else statement. But essentially what happens is this last argument is kind of a catch-all for everything that hasn't been evaluated yet. So for this first argument, of everything greater than 29.29. If it's in fact bigger, it will get labeled with big, but then everything else kind of gets captured by this true statement that hasn't gone through the test, and then gets labeled with this small category. So the way to think about this is the case when's way of classifying like the else part in the statement. And so that's great. But let's take a look at the two categories that we made. So let's select specifically hindfoot length and hindfoot cat. And we'll just look at a few of the results. And so what we can see is that the top two values were classified correctly, but then we can see here that the NAs have been put into this small category. And that's because of how we set up the case when function, where basically everything that wasn't big was just put into the small category. So that's not correct and it's problematic. So we need to add another argument or test. And so I'm going to add this right below line 21, so in line 22, and we need to put some sort of test here for NA. So is.NA, or one of our favorite functions that we've used in class so far. So we'll do this for hindfoot length. And if it is NA, we'll set this to NA character. And we haven't seen NA character yet in class, but essentially it is R's way of knowing that this value is NA, and because this vector is a character vector, this NA is also going to be a character. So you can check out R's NA classification, but there are a few different types of NAs that you can specify. So there's also like an NA integer if you did want to add an NA to a vector that was an integer. So that's kind of just a side note there. But yes, so when we run this, now we can see that NA has been correctly classified as NA. So one last thing I want to talk to y'all about is if there are more categories. And so we can copy lines 19 through 26 and work within this code that we've already written. And so right now in line 31, I have everything greater than 29.29 is big, but let's change that to 31.5. And this is just arbitrary numbers. And let's add a new argument. So hindfoot length equal or greater than 29, and we'll make that medium. And then let's keep everything else. Oops, we can keep head too. Okay, so we'll keep everything else and run this. And do. Okay, so I got an error. Basically, it's saying unexpected symbol. And this is classic mistake I make in case when is I will forget to put a comma or a parenthesis. It's really easy to just miss little pieces of the syntax like this. So basically every conditional argument that you write, you have to put a comma after so that R knows like, okay, this is one conditional argument, and then this next one is a separate one. Okay, so now if I run it, that looks good, but we can't really tell right now how many are in each category and kind of just like the breakdown of this column that we've made. And so something else that we can do is actually use that group by function that we talked about last week. So let's group by hindfoot cat. And then let's actually tally up or count up the number in each category. So when we use this function, we can now see that there's a pretty similar amount in the big and small. Um, and there's just like a small amount in the medium category, probably because it's quite a small range in that medium group. And then we also have the same NAs that we started with. So that's a good sign that R has correctly captured those NAs even through all of these conditional statements that we've given it. So that's where I'll leave you all with conditional statements. Just as a takeaway, these are really useful when you need to classify or reclassify data. In the case when function is super useful if you have a lot of different conditions that you want to be able to set these classifications for in your data. So thanks all for listening, and we'll see you soon.